Welcome to this course on ClickHouse. ClickHouse is an open source database management system meant for real-time analytical applications. ClickHouse was originally developed by Yandex, and the name ClickHouse is derived from two words, clickstream and data warehouse, based on its first ever use case at Yandex Metrica. My name is Vijay, and I will be your primary instructor for this course. Before you begin, it is recommended to have a computer with 8 gigs of RAM, 50 gigs of hard disk space, and Linux or Mac operating system installed. When it comes to software, you are expected to have knowledge on basic Linux commands, the basics of SQL, and you are expected to be comfortable with Docker and Docker Compose. ClickHouse is a super fast analytical database, and in fact, it is faster than other prominent analytical data stores that are currently available. The benchmarks comparing ClickHouse with other prominent analytical data stores are available in benchmark.clickhouse.com, and you can verify the results comparing ClickHouse with other analytical data stores and draw your own conclusion. ClickHouse has a lot of useful inbuilt integrations using which we can connect with external data sources, streaming engines like Kafka, data lakes based on Delta Lake, Apache Hudi, Apache Iceberg, etc., and analytical and visualization tools such as Grafana, Metabase, Apache Superset, etc. ClickHouse comes with language drivers to Python, Java, C++, Node.js, Go language, etc., using which we can programmatically interact with the data in ClickHouse database tables. In addition to this, ClickHouse database has a vibrant and helpful community. ClickHouse is already adopted by many prominent organizations, and if you have not learned how to use it, then today is the right time to begin. This course has around 80 lecture videos, 300 plus examples, and 200 plus quiz questions, and the contents are spread across 10 sections. We will begin the course with an introduction to ClickHouse, installing a single node ClickHouse server, and connecting to a ClickHouse server to query the data. Next, we will cover the basics of ClickHouse SQL, the operators, and data types available in ClickHouse. In the third section, we will cover the important and commonly used inbuilt functions that are available in ClickHouse. Next, we will cover the merge tree family of table engines, which forms the backbone of ClickHouse database. It is the most advanced and feature-rich table engine in ClickHouse. In the fifth section, we will cover the log family of engines that are used for lightweight workloads. Next, we will look at different special table engines that comes with ClickHouse. In the seventh section, we will cover the multi-node ClickHouse setup and look at topics such as data replication and sharding in ClickHouse. In the eighth section, we will see various integrations available in ClickHouse to connect to external data sources. Finally, we will cover topics such as configuring a ClickHouse server, performing role-based access control tasks, and maintaining a ClickHouse server. Once you complete this course, you will have a solid understanding on ClickHouse and its usage. This course has more than 300 examples demonstrated across the topics. And in fact, this course is built around these working examples. Throughout this course, you are required to work through the examples that are demonstrated in the video lectures and practice them. Watching the videos without practicing is definitely not going to help in learning ClickHouse database. Also, you will have a short quiz at the end of most of the videos to test your understanding. While answering the questions, you are encouraged to search the internet or refer the official documentation. Take sufficient time to understand and grasp the concepts. And if you feel like the videos are too fast, you can reduce the playback speed in the Udemy video player and vice versa. If you are stuck somewhere or have questions to ask, you are encouraged to ask them in Q&A section of the course, and I'm always happy to help you out. Thanks for choosing this course and happy learning. Welcome back. Let us look at the history of ClickHouse database. ClickHouse started as an experimental project at Yandex for Yandex Metrica. Yandex Metrica is a free web analytics service offered by Yandex that tracks and reports website traffic. ClickHouse went into production use in the year 2012 at Yandex for Yandex Metrica. ClickHouse was open sourced in the year 2016 and released to public use. In the year 2021, a new entity called ClickHouse Incorporated took over its development and maintenance. We have seen that Yandex Metrica is one of the earliest adopters of ClickHouse. As of the year 2020, Yandex Metrica had one of the largest ClickHouse servers with hundreds of nodes. They had a cluster with 630 nodes, one with 360 nodes, and another huge cluster with more than 1800 nodes. The total storage was around 118 petabytes, and they had stored around 120 trillion rows. In case if someone has any reservations or doubts regarding the ability of ClickHouse, this example should put them all to rest. ClickHouse is a columnar database. ClickHouse database has lot of similarities with traditional databases, and yet it is different. Like the traditional databases, the data is stored in tables. The table consists of rows and columns. But it differs from traditional transactional databases from the way the data is stored in the disk. A tabular data can be stored in row format as in traditional databases or in columnar format. In row-oriented databases, all the rows in a table are physically stored sequentially in the hard disk, whereas in a column-oriented database, each column is stored as a separate file, and within the file, the values for those columns are stored sequentially. In general, row-oriented data stores are good for write-intensive operations, and column-oriented data stores are good for read-intensive operations. In this example, we have a tabular data which is on the left with 4 columns and X number of rows. If in case this tabular data is stored in column-oriented format, we would end up in 4 different files, and each of these files would correspond to different columns in the tabular data. For example, file 1 would correspond to the name column, file 2 for the ID column, and so on. Within each file, there would be X number of values for that particular column since we have X number of rows. So while reading the data, we can read only those files which are required, and we don't have to scan through all the data in the disk. Let us look at the key features of ClickHouse. As mentioned before, ClickHouse is optimized for speed, and ClickHouse supports SQL. The ClickHouse dialect of SQL is quite similar to ANSI standard, and it has a lot of useful inbuilt functions. ClickHouse is easily scalable, and it is quite reliable. When it comes to reliability, ClickHouse supports data replication, and a ClickHouse cluster is easily scalable and supports distributed data processing through sharding. ClickHouse comes with a lot of useful tools and integrations with external data sources. For example, we can connect ClickHouse to prominent databases like MySQL, Postgres. We have options to store the streaming data from Kafka or read the data that is stored in AWS S3 storage. Apart from this, ClickHouse is also famous for its community, which is quite supportive and helpful. So when to use ClickHouse database? ClickHouse can reach unmatched speeds when the number of reads is very high when compared to the number of writes in the database table. ClickHouse does well when the data is inserted in large batches and the tables are denormalized. That means the tables have large number of columns and the data is stored in a single white table instead of multiple related tables like in transactional databases. Note that ClickHouse is not designed for transactions, and more commonly, while querying the tables, the data is either filtered or aggregated. In the upcoming videos, we shall begin by installing ClickHouse and begin our journey towards learning ClickHouse. Thank you and see you again.